Hey guys, welcome to the last unit of the year for seniors. This is kind of just a tiny taste of calculus. Juniors, it's a little bit more of a taste because you're going to do a couple extra lessons. Seniors, this is your kind of last week of material. And juniors, you'll have one additional week after this. So the way it's going to work is a couple lessons this week, a couple lessons next week, ending in a quiz. Seniors, you won't have to take that quiz. That's just kind of a rite of passage, right? Being a senior, you don't have to do the last kind of couple things. This unit's on derivatives. So derivatives is a calculus topic, and we're just really going to give you like an intro to it. We're going to talk about today something called the limit definition and something called the power rule. My thought of the day for all of you is this. True story, Isaac Newton invented calculus while quarantined during a plague. So if he can do that, then I think you can learn about it for a week while quarantined during a pandemic. Kind of just an interesting fact. So let's get into it, guys. A derivative, in general, it's a way to show a rate of change at an exact moment. And you've heard of rates of change before. They're also known as slopes. Okay, so if I want to know, like, what's the rate of change? How fast is this function changing? Boom, at this exact moment, at x equals 2, at 3 seconds, so on and so forth. That is a derivative. Okay, if I look at a curvy function and say, what's the rate of change at x equals 2, what we're actually looking for is a derivative at x equals 2. So the reason we call that an instantaneous rate of change is because it literally is the rate of change at an instant moment. So that's another way to think of a derivative. It's an instantaneous rate of change. This is definitely different than the average rate of change. So the average rate of change is, the rate of change over time. Okay, so that might be like miles per hour. That's usually an average rate of change. It's not like exactly at this moment, how fast are you going? Anyway, to find that instantaneous rate of change, we take the limit as h approaches 0 of the average rate of change from 2 points, x equals a and x equals a plus h. So what that means is take the first point a and just go a little bit past it, maybe h units, and that gives me my second point, a plus h. And we take, so the average rate of change between these, if we take the limit, as this goes down to 0, it gives us our instantaneous rate of change. That might sound confusing, and you don't have to memorize all of that, what it means, and so on and so forth, but you do need to know that a derivative is an instantaneous rate of change. Now, the secant line that's drawn in green here on this graph is called an average rate of change. Okay, so it's just the rate between 2 points. That's what you guys have always done when you find a slope. You've always found an average rate of change. The tangent line, here it's kind of a light purple, but I'm going to highlight it in blue. The instantaneous rate of change is a tangent line, and that is the derivative, okay? And so that's this formula, which I wrote down here. Okay, so this is the formal limit definition of a derivative. Okay. Now, in the past, we really dove into this limit definition, and we had you guys work a lot with it, but because of what's going on in the world, we're really just going to kind of zoom past it. We are going to do one easy example with this limit definition, but we're going to get into a shortcut pretty quickly. So in terms of notation, there are 3 ways that we are going to see quite often in terms of how to say we're looking for a derivative. So here's the first one. The way I read this is f prime of x, f prime of x. So this apostrophe in math, we say prime, and what that means is I want to take the derivative of the original function, which would be f of x. Another way to notate a derivative is y prime, means the same exact thing as f prime of x. It's just that the function is y equals, so y prime would be, we're looking for the derivative of that function. And the last way that you'll see a lot more probably next year is this. It's the way we read this is dy dx. It's not dy over dx, it's just dy dx. And again, that means the exact same thing as f prime of x and y prime. It just means take the derivative. Technically, this means the derivative of y with respect to x. All right, but these all mean the same thing. They all mean take a derivative. So how do I find the derivative? Well, what I want to do to find a derivative is find the limit as h approaches 0, okay, of f of x plus h minus f of x all over h. So I like to break it down into steps. So first, let's go ahead and find that f of x plus h. They give me in this problem, example 1, that we want to find the derivative of f of x equals 2x. So if I find f of x plus h, what that means is that I'm going to take x plus h and I'm going to plug it in for x into the function. So I'm going to replace that x with x plus h. Distribute that 2. So f of x plus h in this case is 2x plus 2h. Second step, find f of x. Well, they gave me f of x. F of x is just 2x. Now I'm going to take f of x plus h, which was this bright blue, and I'm going to subtract f of x. So 2x plus 2h minus f of x, which is 2x, and simplify that. So the 2x's cancel and I get 2h. So now the next step is to take that and put it over h. Okay, again, so I've done f of x plus h minus f of x. Now I'm going to put it over h. And what happens? The next step says to simplify. The h's cancel, and I get 2. Now my last step is to now take the limit. So I'm going to take the limit as h approaches 0 of 2. And as you guys learned in the last unit, if there's just a number here, then the limit is just that number. So the answer to this is 2, which means at the end of the day, f prime of x is 2. The derivative is 2. Okay, now that didn't seem too bad. However, once I get into harder problems like maybe a quadratic, things start to get a little crazy. So I worked out an example for you with a quadratic. So a quadratic means x squared. If I find f of x plus h, guys, when I plug in x plus h for x, I have to FOIL it. Dang. And when I FOIL it, I get this part. Drop down the 2, and that's how I got this green part. You might hear my baby in the background. He's right next to me, just kind of waking up from a nap, breathing heavily. So nothing to be alarmed of. It's just a little baby. He's 3 months old. All right, so then here's f of x. When I subtract f of x plus h minus f of x, I have to distribute the negative. And as you can see, some things will cancel out. I'm left over with this pink part. Uh-oh. And I put that pink part over h. I then have to simplify. So to simplify in this situation, I have to actually factor out the h and cancel and then take the limit. And in this case, when I take the limit, there is an h. So I plug in 0 for h, and that's how I got my final answer, which was 2x. This is a much more complicated situation. In the past, we had you work out a ton of problems like this, but because of the circumstances, we're giving you the shortcut early, and you're going to get to use it. The shortcut is a formula, although I don't like to think of it as a formula. So this is the formula, but I'm going to talk about how easy it is to do. So if I have a function ax to the n, that looks scary, but this is like having a 5x squared, for example. Okay, like where the a is 5 and the n is 2. So it's just a normal looking function. To find the derivative, the trick is to take the exponent, drop it in front, and then multiply that a value by it. And then what we do is reduce the power down by 1. So subtract 1 from the power. It sounds scary, really not that bad. Instead of thinking of the formula, I really think of these 3 check marks. The first one saying, drop the exponent to the front. If we need to, we'll multiply. Reduce the exponent or the power down by 1, and any constant is going to turn to 0. It's basically going to go away. Okay, so let's try it. First example, to find f prime of x, when f of x is x squared, we take the exponent, drop it to the front, and then reduce the power down by 1. So subtract 1 from the power. 2 minus 1 is 1. The way I would personally write this answer, I'm done. I mean, the way I would write this answer out personally is just f prime of x equals 2x. Because since it's x to the first, I don't have to write that first power. It's the same thing as just a 2x. Guys, I'm done. Instead of doing all of this, I just did the power rule and found the derivative, which is much quicker. Let's do a harder example though. Okay, so first part. So you're going to do this derivative in parts. So the first part is the first term. Drop the 3 down. Now this is a situation where I do have to multiply. Okay, so 3 times 4 is going to give me 12x, and then reduce the power down by 1. So the power goes down to 2. Now, I don't have to write this out. I can do that part in my head. I just wanted to show you where I was getting the 12 from. And then here, any constant, so any plain number, goes down to 0 when you take the derivative. Do I need to write the 0? No. That's why I said it kind of just goes away. So my final answer is f prime of x equals 12x squared. Okay. All right, 2 more examples, and I'm not going to over-explain because you guys basically get the gist, I'm sure, by now. So we drop down the power and multiply. So 2 times 3 is 6. This is going to be x to the first power because I dropped the power down by 1. I'm not going to write x to the first. Now this part's kind of weird, though. I will write this down. There is an invisible exponent here that's a 1. So if I drop that exponent down, 2 times 1 is 2. Technically, this does go down to x to the 0. But what is x to the 0? X to the 0 is 1, okay? So what is 2 times 1? It's just 2. So the moral of the story is this. For all linear, we are going to drop. I'm sorry, my husband just walked in the room. He's on the phone, so you might be hearing something in the background. So all linear terms, what happens is the shortcut is just that x goes away when you take the derivative. Okay, so that's the shortcut. Now with constants, the shortcut is that just goes away to 0. I don't have to write the plus 0, so my final answer is f prime of x equals 6x plus 2. After like 15 minutes of filming, I'm not gonna stop the video, so sorry for all the background noise. Last but not least, let's go a little bit quicker here. Drop down the 4. 4 times 4 is 16. X to the third. I drop my exponent down by 1. Next part, drop the 3. X to the second. Next part, drop the 2. 3 times 2 is 6. Oops. X to the first, which is just an x, minus 9. The x just goes away. Technically plus 0, but I don't have to write that. And I'm done. Whew. All right, guys. So hopefully that sticks, but we're going to do a little bit more of the power rule next lesson. Try out the problems for homework and see how it goes. Thanks.